Hello viewers, in today's class we are going to take up one important conceptual problem in definite integrals, right? So here we have this definite integral which involves a signum function, right? So here we have to evaluate the integral from -2 to 2 x minus 1 and signum of x minus 1 over 2, right? So let us start. So let us first call this integral as I, right? Okay, so now let us first assume that the function phi of x is equal to signum of x minus 1 over 2, right? Okay, now from the definition of a signum function, we know that signum of say y is equal to plus 1 when y is greater than 0, and signum of y is equal to 0 when y is equal to 0, and signum of y is equal to minus 1 when y is less than 0, right? So this is the standard definition of signum function, right? So here we are given the function as signum of x minus 1 over 2, right? So if we replace this x minus 1 over 2 by y, we get phi of x is equal to plus 1 when x minus 1 over 2 is greater than 0, right? And signum of x minus 1 over 2 is equal to 0 when x minus 1 over 2 is equal to 0, right? And signum of x minus 1 over 2 is equal to minus 1 when x minus 1 over 2 is less than 0, right? So we have written this function phi of x using this standard definition, right? So from this inequality we see that x minus 1 should be greater than 0, which implies that x is greater than 1, right? And if we solve this integral this equation, we get x minus 1 is equal to 0, that is equal to x is equal to 1, right? And if we solve this inequality, we get x minus 1 is less than 0, which implies that x is less than 1, right? Okay, so now we see that here this given function phi of x, which is signum of x minus 1 over 2, is equal to plus 1 whenever x is greater than 1, right? And this function is equal to 0 whenever x is equal to 1, and this function is equal to minus 1 when x is less than 1, right? Okay, so now let us take the real number line, and here we have minus infinity, here we have plus infinity, and we see that here we have x is equal to 1, and see here we have to integrate this function from minus 2 to 2, right? So minus 2 lies somewhere here, and 2 lies somewhere here, right? Okay, so now if we analyze this definition, we see that signum of x minus 1 over 2 is equal to plus 1 whenever x is greater than 1. So this interval or this portion of the number line corresponds to x greater than 1, right? And here we have this open circle which indicates that we have to split the limit of integration at x equal to 1, right? And when signum of x minus 1 over 2 is equal to minus 1, then we have x less than 1. So this portion corresponds to x less than 1, right? Okay, so now we have this integral I as minus 2 to 2 and x minus 1 and phi of x, right? So here we are denoting signum of x minus 1 over 2 as phi of x, right? Okay, so now let us split this integral as a sum of two integrals. So first is from minus 2 to 1, right? So from minus 2 to 1 we have x minus 1 phi of x dx, right? And the second integral is from 1 to 2, right? And here we have the integrand x minus 1 and phi of x dx, right? Okay, so now let us once again go to our definition. So phi of x is equal to plus 1 when x is greater than 1. So we see that here phi of x should be equal to plus 1, because see x varies from 1 to 2. So when x belongs to 1 to 2, then obviously phi of x is equal to plus 1, right? And here when x belongs to minus 2 to 1, then phi of x is equal to minus 1. So here we have minus 1. For phi x we have minus 1, because in this case x is greater than 1, and in this case x is less than 1, right? So now we can rewrite these two integrals as minus 2 to 1, and here we have x minus 1, and for phi of x we can write minus 1 dx plus 1 to 2 x minus 1, and here we have plus 1 dx, right? Okay, so now we can simplify this expression as minus 2 to 1, and we have minus x plus 1 dx, multiplying these two terms by negative 1, and here we have simply 1 to 2 and x minus 1 dx, right? Okay, now we have two simple integrals, and we can solve these two integrals by using the known results. So the integral of x is x square over 2, and the integral of 1 dx is simply x, and the limits of integration are from minus 2 to 1, and here we have the integral of x is x square over 2, and here we have minus x, because the integral of 1 dx is x, right? And the limits are from 1 to 2, right? Okay, now we can simply substitute the limits and we'll take the difference. So now we have 1 square over 2 plus 1 minus, and here for x equal to minus 2 we have minus 2 square is 4, so we have 4 over 2 and minus 2, right, for x is equal to minus 2. And then here we have 2 square, that is 4 over 2 is 2, and here we have 2, and then if we take x is equal to 1, then we have 1 square is equal to 1, so we have 1 over 2 minus 1, right? Okay, so now we can simply do the calculations here. So we have minus half plus 1, that is simply half, and here we have minus 2, that is minus 4, and here 2 minus 2 is 0, and half minus 1 is minus half, right? Okay, now we can simplify it. So we have half minus multiplied with minus 4 is plus 4, and here we have plus half, right? So half plus half is 1, and 1 plus 4 is 5, right? So viewers, the value of this integral is equal to 5, right? So this is how we can find out the value of this integral by making use of the concept of Signum function.